We just had Alex join us. Welcome, Alex.
Can you see my practical IoT at scale,
can.
Shannon? Very good. Okay.
So let me go ahead and kick off. My name is Shannon Duvendak, and I lead the IoT Peoria meetup. This is an organization that is for technology enthusiasts. So people who are trying to solve problems, and they're trying to use technology to solve those problems. It's a group that's, it's a casual group. It's one that we use to be able to share ideas, learn different technology, learn how other people are trying to solve problems. It does say IoT, so IoT is kind of the base, but if you think about IoT and the whole stack of what IoT is, this gets into all kinds of technology between whether it's a telematics device, it's the telecom to try to bring data back, or it's the data that you put and where you store it, or all the machine learning and all the other type of technology that you try to make, I guess, good insights out of the data you're bringing back. So it's pretty broad in the technology, and we can go to all different types of technology in this group. And again, just trying to share ideas on what you can do with the data to try to make better products or solve different problems. So that's who the IoT Peoria is. Tonight, I'm very excited about having Lenovo come in and talk about a practical IoT at scale. And our speaker tonight is Charlie McNiff. He is the manager of the Smart Edge and IoT Solutions for Lenovo. Very smart guy. I did look him up on LinkedIn. He is an electrical engineer by vocation, both his undergraduate and his graduate degree. He has a wealth of experience, over 20 years within the field of IoT, more on the technology side and at the edge. He is an expert and very capable of building secure and capable industrial IoT remote infrastructure, solving the OT side of the OT to IT integration problem. So basically that means taking the physical objects out there in the world and bringing that into the digital world. He does both sides of the four walls, whether it's at a plant or a hospital or outside in the wild, at the external devices, and bringing that data back into the cloud server. And this is all over a cellular network. So please join me in welcoming Charlie McNiff, and he's going to be our speaker tonight. So welcome, Charlie.
Thank you, Shannon. Thank you very much for having me today. I appreciate the opportunity to join your group, and I'm sure I'll be joining many sessions in the future as well to learn as well, stay current. So I want to talk a little bit about what is edge computing. There's for any newbies, basically, I think you summed it up pretty well. We're digitizing the physical environment, whether it's new sensors to digitize something that's never been digitized yet, or whether there's existing machines that may have sensors already in them, but they have some complex protocols through their PLC controls layer. So either way, we're going to talk to these different sensors and machines through all different kinds of protocol software, get that data into an edge computer, do some edge processing, look for a fault, is the temperature overheating on the engine? If so, send an alert up to the cloud. If there's a problem trending, maybe send all of the raw data up to the cloud so we can do some deeper analytics. So this is edge computing in summary. Lenovo is launching smart edge computing at scale across multiple verticals. So we're bringing a handful of SKUs, of hardware computing platform SKUs, that we believe meet most of the use cases across major industry sectors like manufacturing, healthcare, smart buildings, and retail, where we think we get the most volumes. That's going to help us get economies of scale, really drive the cost down for edge computing for all these different industrial IoT use cases. And I'm going to go a little bit more into the manufacturing one here. So there's tons of use cases. COVID-19 is a really hot use case right now, and we've got turnkey solutions through partners for temperature monitoring, access control, social distancing, what do we call that one? For social distancing, contact tracing. So this is really important, and I'll talk about that a little bit more on some future slides. Monitoring power. Is the power clean in the building? If the power's not clean, the equipment can fail, and you don't even know what's happening. Little spikes in energy. So many different things. Monitoring cameras for safety, security, quality inspections, Cameras are the new sensor of today, doing everything. They're counting bottles going by. They're, looking if someone has their hard hat on or their orange vest. There's so many things cameras can do now. The algorithms are getting so much smarter for computer vision software, and that drives a lot of compute. Sensors for line speed, monitoring inventories of product, inventories of raw goods, inventories of spare parts. There's so many things to be monitored. Viewing and managing condition-based operator alerts. AI and machine learning, that drives a lot of compute. So all this data can come into an edge server and run some AI and machine learning or AI inferencing algorithms to produce some results, looking for some trending patterns, and then send new patterns up to the cloud if it detects a new pattern. Right, safety and shutdown alerts, right? Do people want to count when the machine shut down? Why did it shut down? For what reason? Fault codes, etc. There's so much data in a factory, and we're involved in a lot of these types of projects through our partners to make it super easy to do that kind of data collection and make those projects much more economical and much more productized than traditional in the past. Edge computing comes in many forms. So, it could be in the form of a small, lightweight, rugged, fanless edge gateway, which has lots of I/O to talk to the things, right? The robotics, the PLCs, the cameras, the sensors, etc. You want to have lots of protocol translation. You want to have digital I/O, analog I/O. You want to have, Ethernet ports and serial ports and USB ports. We have a family of industrial rugged fanless gateways that have all that and do partners software to do protocol translation and all that stuff, so they can basically get all that data normalized. Then we want to do different workloads with bigger edge workstation-like PCs for event stream processing, batch processing, rules-based actions, machine learning or AI, what's called inferencing algorithms, looking for a condition and then sending an alert. Then big servers at the edge doing machine learning training. These are where the training algorithms run, or local analytics and big data and visualization servers. So these require some even heavier servers. So there's different computes for different workloads at the edge, and we help our customers economically scale all that compute so that it's feasible to deploy this stuff. We understand edge challenges. We understand it's about rugged deployments, longer product life cycles, security. We have some of the best security experts in the world, and it's built into our products and our processes. We know how to manage these devices. We've got software partners that help us with device management and, life cycle management of those assets. We know we have to integrate with your products, with your business processes, and we have partners that help with that, and limited physical access. So there's some nice, very small form factor edge PCs and workstations that will really kind of fit your size limitations as well. Like I said, the edge is evolving. Gateways are driving, the devices need to do more and more around machine learning, computer vision. They're going beyond just data collection to do more business and operational actions at the edge. So less in the cloud, more at the edge is sort of what's happening right now. And more performance is therefore needed in the gateway. Again, more computing power, purpose-built, rugged, fanless, lots of I/O, and the ability to deliver certified solutions at global scale, because we are a global company. Security at the edge, I can't talk enough about security. We have lots of experts that can talk about this, but in our processes, in our supply chain, and most importantly, in our devices, through Think Smart products have what we call Think Shield and TPM secure processing, so, separate chips for secure key lockers and everything. So really, we take security very seriously, and a lot of our ISV software partners will integrate to that unique security layer to have a unique value prop as an appliance for that software running on our hardware. We will do preloads for those ISV software partners. We will drop ship globally. We will kit with partners like Arrow and Insight and CDW and others. So we can basically create solutions, preload software, kit it up, drop ship it globally in 180 countries. And you can source globally from us in local currency, and you can get local service and support, same day on-site service and support in any country, most countries in the world. This is the value of a Lenovo Think Smart product strategy. You can go global and you're covered. All the stickers to go through every country too, certifications and stamps for mobile network operators, and FCC, UL, all that stuff. So it will breeze through customs if you build a product on our hardware. Again, the main drivers for edge computing are economics, not just bandwidth economics, but server economics. It's lower cost to build a lot of the stuff at the edge on edge compute than it is in cloud storage, but latency, there's a lot of latency going up to the cloud, bandwidth economics of cellular especially. You don't want to send everything to the cloud anymore. autonomy. A lot of machines need to run autonomous, either for safety or for other reasons, or just because they're not connected to a network all the time. Maybe a mining machine, sometimes it has satellites, sometimes it doesn't, sometimes it has cellular, sometimes it doesn't. So a lot of these things need to run autonomously. And then data privacy and data custody is common reason for edge computing. What are the drivers for edge computing and the why we need more edge compute? Again, AI, artificial intelligence and machine learning requires a lot of compute at the edge. Things like predictive maintenance are built around AI and ML models. Computer vision, there's a lot of stuff going on with computer vision now. It is the new sensor for all kinds of process improvements. A lot of compute there, working with people like IBM's Maximo Visual Insights group and some other computer vision partners. IoT devices, there's lots of IoT stuff to be integrated. ARVR, this is great for training or for remote expert support. And blockchain is driving a lot of compute, and then robotic process automation. And then when I say robotics, not just a machine that's basically putting bolts onto a Caterpillar bulldozer in the factory, but also automation through robotics and autonomous vehicles inside warehouses, etc. We have a complete portfolio of computers and AR/VR goggles and tablets and digital signage and workstations and fanless edge computers with lots of I/O and digital I/O and serial ports, ruggedized form factors. We have some small form factor workstations that have lots more compute and GPUs, bigger edge servers with GPUs, and even bigger edge servers with even more GPUs. So you name it, we can basically put together the ultimate edge architecture economically for you. We also have great partners. So we're not just selling hardware. We're not just selling a commodity. We do think we have the best hardware in the business, but we're backed by a partner ecosystem for IoT and OT Edge solutions. Biggest being Microsoft Azure and Amazon Web Services. We are Azure IoT Edge certified. We are Amazon Greengrass certified. We are on their certifications list on their websites. We work with partners like Software AG, who have their Cumulocity IoT device management platform. Really shortens the development cycles for our customers. Teles for their DeviceWise platform. They integrate to all these different PLCs and sensors. Lawson's got an industrial application platform. Mesh and Clica, these guys are really, Clicatech, these guys are really rich. Mesh is kind of really strongly aligned politically with Azure, and Clicatech is really strongly aligned politically with Amazon, but they both will work on either platform. But if you really want to have better political alliance with Amazon, Clicatech's great, Mesh is great with Azure, but they both will do custom sensor projects. They'll come in, they'll consult with you, do business process, value prop analysis with you. They'll do sensor selection with you, for you. They'll basically build the whole end-to-end web app, all the edge computing logic. They will turnkey everything for you, and they've done a million projects. They've got lots of use cases. They make IoT easy, and they make it scale. PWS is a cellular partner, so they do all anything to do with cellular. They make that easy. Scale computing, distributed edge computing, make a bunch of edge computers look like a virtual pool of compute. And Edge IQ for device management, Clovity, and there's another partner Thinglogix for back to work solutions. I'll talk about that. SAS in the energy and manufacturing sectors for all kinds of analytics and computer vision. Then IMS Evolve with a lot of smart building type solutions. So Lenovo Industrial IoT for manufacturing. So I see two major areas. Either you're connecting your factory floor so you can optimize how you build your products. You want to get more product out of your factory at a lower cost structure. That increase the performance and productivity of your factory. That's what I call connected factory, or a machine owner. A factory is the owner of a machine, and he's connecting his assets, right? Then there's the connected product strategy. That means the product that leaves the factory will be connected to become a smart product, so you can provide more business value to your end customer, the customer that owns that product. Some cases, a manufacturer is also a machine builder. So this, with like an example, would be Caterpillar. They both have connected factory floor initiatives, so they can build connected machines better, but their machines are also connected to provide business value to their construction companies and maritime companies and rail companies. So we're going to go into basically these two broad categories for the rest of the presentation. So how does your factory look today? Well, if it's not connected, you're really not seeing it. You got lots of islands of automation, okay? Now, as you connect it, you have lots of control points, PLCs from Mitsu, Omron, Siemens, Rockwell, back off, you got tools and all kinds of drill handsets. You got people you might want to connect through sensors to do labor utilization or OSHA compliance. And you want to connect all this stuff back into all these back-end business systems or third-party cloud systems. This becomes a nightmare for a lot of manufacturers. There's a lot of custom code going on today, and it doesn't need to be that way. SI, systems integrators, love to bill hours. That's how they make money. They're billing hours of people, right? They need to know that there's better tools to be more efficient. They can do more projects more efficiently. So if you're a manufacturer, you should tell your manufacturer there's better tool sets like Teles Industrial IoT Suite, powered by their DeviceWise software platform. So it's basically a codeless environment. They have all the drivers to all these sensors and PLCs and RFID readers, barcode scanners, and printers, and nut runners, and paint booth systems, and they can talk to all these systems out of the box. They can pull the data out of them without having to write any custom code and publish it to any back-end business system, MES systems, ERP systems. There's a lot of MES migration strategies where people are trying to reduce the number of MESs and flatten the data architecture so that basically they get a view of all the data in the factories. DeviceWise makes that super easy to do, and do some edge logic and processing before you filter. You can filter that data. You can do some persistent data storage, or you can send it up to the cloud. So it's point, click, drag, drop to these business systems on-prem, or back up to third-party cloud platforms. You can also bring in data from remote sites, maybe a remote autonomous site, and you can do all kinds of secure remote access tunneling. So this is a very powerful tool set. If you're trying to get access to all the data in all of your different building systems, whether it's Siemens, Honeywell, Trane, Schneider Electric, Eaton, we work with a partner called Tritium to talk to all these different building systems. So a lot of manufacturers may be also trying to get access to this data, because maybe when the HVAC system is down, that's going to affect the process. So they want to mash up that data with process data. Maybe if there's a problem with power, right, they want to basically know what's going on. Maybe they also want to know how much power is being used to manufacture that particular product on that particular day. Is it cheaper to manufacture it at night or on a different day when power is cheaper, right? So they're mashing up cost of power versus cost to build that product. It becomes a cost model for building that product. So there's a lot of building facility data they may want to get access to. Now, let's see, where am I? A second. Okay, so mashing up visualization on the plant floor. There's plenty of tools in the cloud, like in Azure and AWS, but if you're going to do all kinds of web apps that are on-prem, they have lots of tools, tool sets to be able to build out these dashboards and OEE apps very, very quickly. A lot of pre-canned applications, shall I say. Let's look at some examples of how this was deployed on the factory floor. So connected factory floor IoT use cases, many different types of sensor use cases, all in a common compute platform for Lenovo. Vibration analysis, in warehousing, sensors and cameras, PLC integration, computer vision for quality control and process control, right? Environmentals for OSHA compliance, temperature, fumes, lighting, noise pollution, paint booth. How do you basically prove to OSHA, hey, there weren't loud noises hurting my employees, there weren't fumes hurting my employees? Electrical power. There's just 1,000,001 sensor projects that can all be implemented on small, thin client edge computers. Here's an example of one specifically, I'll go into more detail. This is a tier 1 tire manufacturer. We're involved in this project right now. There's over 6,000 curing machines they have across 30 factories globally. A curing machine is basically an oven to bake a tire. And if the temperature's off at all during the process, that tire has quality problems. That means either customer dissatisfaction or worse, maybe lives on the road, right? Depending on how bad that tire damage is, right? So Teles basically came in and with their software, but they also packaged on our edge devices here, small form factor edge computer, but they also did all the sensor selection for a high value, high quality temp sensor, validated and tested all this. We're gonna kit this up for them. We're gonna preload the software for them. We're gonna drop ship this globally for them to this tire manufacturer all over the world. So another systems integrator is coming in, kind of like a Deloitte or an Accenture type company, to do all of the cloud-based AI, ML analytics to build this a portal for the quality and service teams. So, but we came in. We're not in this side. We're on the OT enablement side. There's plenty of big IT companies out there, or a customer might do this themselves in some cases. This might be a CIO-led initiative, or it may be done by a systems integrator. But we're really doing the OT enablement layer. So warehouses, there's a lot of smart warehouse initiatives going on around robotics and autonomous vehicles, blockchain tracing, driver behavior, computer vision, drones, computer vision in drones, drones flying around inside of warehouses with cameras on them. It's amazing the stuff that's going on. Sensors, AI inferencing, worker safety. So there's all kinds of projects. There's a lot of customization that's going on in the warehouses, and we've got partners that are doing really, really amazing stuff here. End-to-end solutions for back to work. This is hot right now, and this is probably the most turnkey out of the box, off the shelf thing we've got. And we had to get it there because everybody wants it, everybody needs it. Half the people have implemented it, but some of it's not working exactly the way they wanted it to, and they're going back to the drawing board because either they've selected the wrong type of camera, temperature monitor. So there's a lot of temperature sensors out there that are really not up for prime time. So you want a high quality thermal imaging camera to get a real full body scan of the temperature, because skin temperature alone isn't good enough. So we're controlling who gets into the building. We're integrating that into these building access control systems, into the badge swiped readers, into the time management or badge time clock systems. So a real full integrated solution, managing behaviors within the space, putting up digital signage to display policy, safe workspace monitoring, on-premise contact tracing, right? This is really important as step 3. If somebody was sick with COVID and I knew very accurately how many people were near each other, then basically we could very isolate, say only these 3 people need to be quarantined, or these 5 people need to be quarantined if you go back and look at the data. Today, with inferior indoor location accuracy, there is basically, by the way, if somebody's not on mute, I can hear some background noise. So FYI, whoever you are. So without good location-based technologies, you have to quarantine maybe half your plant. And this is basically, I'm seeing this use case even with people that are doing like some of the vaccines that are, retrofitting factories for vaccine deployments, and they need to basically have very accurate contact tracing. So these are areas that we're really vetted, some really strong partners, and we can do some really amazing solutions there. Connected product is the other use cases, right? So there's many types of industrial machines in the world. You name it: machine tools, packaging machines, medical machines, pumps, rail systems, things in buildings, right? Oil fields, heavy equipment, right? Like Caterpillar, maritime equipment. So they all have the same problem. They want to basically digitize their solutions. They want to get data back into cloud-based applications. All the analytics platform companies have done a great job educating OEMs on the value of remote monitoring. But the OEM then has to be the expert on implementing this. I've had the pleasure to work with Caterpillar in the past. I know they're a world leader in this, but there's a lot of OEMs that really just know how to build great machines, but they don't know how to staff a team around security architecture, sensor selection, network design. How do I deal with cellular network operators? Who do I even call? What kind of software do I need? Is there off-the-shelf software I can configure? Do I got to do custom software? What hardware do I select? This is an entire team of people, and if you haven't done it, it's not for the lighthearted. So we come in with our partners, and basically have partners around device management, partners around data collection and edge processing, and basically we can implement these solutions turnkey. I have plenty of smart customers say, Charlie, I don't need any of your partners to do any of this. I've got that software. I just need a really great next-gen edge computer for my next-gen remote monitoring solution. No problem. I want to sell my computers. My partners help me sell more computers, but if you need a current turnkey solution, we can help you. If you just need a great edge computer, we can help you too. So here's an example. This was a very large manufacturer, I think in the tens of billions of cardboard products, right? So they make the machines that make cardboard boxes, cardboard cutouts. You'd see like kind of the picture of Tom Brady behind a CocaCola stand at a convenience store, and on football Sunday saying 2 for $1, 12 packs of Coca-Cola, right? They make those marketing things, and they also make the cardboard box. Anything with cardboard, they make the machines. So let's say Coca-Cola purchased that cardboard boxing machine. Now the cardboard box machine maker wants to give great remote support, so this guy can do his job better and continue to make more boxes. So that's what's going on. every vendor in the world of every type of machine, doesn't matter what it is implementing this architecture. It starts with basically health of the machine, status of the machine, fault checks, send alerts up to the cloud, and then let people come in, remote experts at headquarters and field service technicians on tablets, and the customer will have the same view of that machine, right? So CocaCola can see what's going on, the OEM support headquarter team can see what's going on, and the guy that's sitting there on his way in the van can see what's going on his tablet. Hopefully he's not looking at it while he's driving, but everybody has a great view of operations. Take it one level further. We're getting involved in ARVR for enhanced remote support. So now the guy shows up, the field service guy shows up in the van, he's at the site, he's like, oh man, I'm not sure what's going on. So he calls up the guy that built the machine, right? I need some extra help, man. And he's coming in with AR, VR, and so it's just like the guy's there. He's telling him what to do this, do that. This is incredible. And they're using it for training purposes. So this is a big area. It's AR, VR hasn't taken off at scale yet, but we're really starting to see a lot more projects around it. Next gen cabs for heavy equipment. We're getting involved in some projects with some heavy equipment makers, and a lot of the cabs today, they have a lot of push buttons, controls, a lot of mouses, and that's what people are used to today. But and there's a multi-million-dollar tooling to go and build all this plastics and all these buttons and all of this wiring to all these buttons, and it's not even that ergonomic and friendly. So we're seeing more and more heavy equipment makers move towards what we call the Tesla model. No, that's not the inside of a cab. That is a Tesla car, but basically I couldn't show the picture, but basically the Tesla model is no buttons, large touch screens, off-the-shelf computers and touch screens, lower cost to manufacture, no custom physical tooling, no custom buttons, no all this wiring to all these buttons. It's much easier to manufacture, easier to add new features. It's what younger operators want. They're used to this. They're used to touch screen functionality. So this is the old guy's tool, and this is the young guy's tool. So we're seeing a trend towards this, and this really means open compute, open standard compute, and digital display. I think Lenovo is going to play really big in that space. So what are healthcare providers doing? So the IoT Edge in healthcare. And by the way, we're going to take lots of questions at the end. If anybody has questions, we're going to have 15, 20 minutes at the end here, so no problem. So what's going on in healthcare? Again, COVID-19, access controls, temp monitoring, social distancing, contact tracing, same thing. All buildings need that solution, whether you're a healthcare provider, whether you're a manufacturer, wayfinding. How do I find my way through the building? Security and surveillance monitoring those cameras, staff resource utilization and scheduling. So where are my employees and which employees needed for this particular patient, and make sure they're all in the right places. Equipment tracking, asset tracking. Where is that particular equipment? Lives depend on it. So asset tracking, medical equipment integration, remote monitoring of that equipment by the vendor to make sure that equipment's working properly. Patient monitoring and telemetry. So this is the nurse looking at all the hospital beds in the ICU, let's say. Again, that's all based on modern IoT technologies. They're all revamping all these old technologies and old wired systems that you see in hospitals today to modern IoT technologies, but they're not IoT experts, so they need help. Remote patient monitoring, putting the right technologies and tools out there, not just in the home, but maybe in CVS and Walgreens, you're seeing kiosks and things like that. Lobby check-in and visitor management. So this digital signage, there's so many things going on around IoT in a hospital. It's incredible. We worked with a tier 1 healthcare provider. They did all the software, but basically they built a complete portal for the whole ecosystem, for all the healthcare providers, all of the labs that do all the diagnostics and testing, and all of the manufacturers all can come together with a common view of nursing and hospital operations so they can collaborate and solve problems faster. This means lives saved. This means lower cost for hospital operators. And we didn't do any of the software here in this case. None of our partners came into the solution. We were just providing a very economical edge compute, highly scalable architecture for them. But this was a pretty cool use case. Very similar. This was not a healthcare provider. This was a provider of lab equipment, kind of like blood analyzers and other stuff that goes into like Quest diagnostics and stuff. All those kinds of lab equipment. They built very similar to the previous one, a portal so that their support team can look at instrument connectivity, look at warnings and alerts, maximize uptime of those machines, and increase productivity of that lab, not only for their own equipment, but they integrated to all of their competitors' equipments too. So now they basically own the customer experience. And then when that customer is ready to put new equipment in, they can basically recommend their own equipment over the competitor's equipment. So this is a very common use case to create that, again, centralized portal for everybody to see the same information. This was another cool one. This was Mannequin training simulators for nursing education. We provide all the compute and IoT inside of this Mannequin simulator. Looks just like all the equipment you'd see traditionally at a hospital bedside to train these nurses. And basically the data is going back to the cloud. So basically remote experts can look at what's going on and give them remote expert support. Tell them do this, do that. Very similar, right, to the use case we see for machines, right? So it's all about just getting the data, moving it to the remote backend systems, and providing that portal for those remote people. This is another one. This was a tier 1 healthcare provider. They own 3,000 dialysis clinics. They also have a machine builder division that builds the dialysis machines. So they're both the healthcare provider and the machine builder. That's not always the case, but in this case they were. And they basically wanted to, again, it's the same use case. It's to put a gateway out next to the machines. In this case, again, they didn't need in the healthcare space, a lot of them already have great software architectures. They had their software architecture done. They just wanted a great edge computer. They had their edge software to talk to the dialysis machine. Since they built the machine, they know how to talk to it. They didn't need help. Like we give a lot of help in the manufacturing sector because we're stronger there. But AWS sends the data to the cloud, and then they built a remote service portal. So basically, again, remote health experts can give this guy that's running the dialysis lab better support to ensure people have a better experience. People ultimately walk out of there alive and with a better experience. So keep that machine up and running and economical for the clinic. So temperature screening and access control. This a little bit more detail on this. We've talked about it a few times here. We have 2 partners, Kiosk Information Systems and ELO Touch Solutions. They are the integrators of kiosks. A lot of the mechanical integration, wiring, and all that. They'll actually go out and install this out in the field and wire it up and Ethernet it up and all that stuff, right? But they're not the software experts. So ThingLogix has a product called WorkWatch, okay? And WorkWatch, let me see if I can zoom in on this. This is pretty cool stuff. Hold on. Try to make this a little bigger. So ThingLogix WorkWatch provides this thermal imaging, right, with all these thermal cameras that are built into these tablets and touch screens. But they can basically have a whole configuration tablet. They can do body temperature, alerts, and alarms. You can set up all the policy of facial recognition. Are you wearing your mask? Workplace checklist automation. It is turnkey for back to work, for thermal imaging, and for a lot of the contact tracing stuff that's going on out there. So this is really cool. So they make the software, and these guys deliver the integrated solution to the end customer, to the hospital, to the manufacturer. So again, just summing up, Lenovo is a market leader. We have a big brand. We're #1 PC vendor worldwide. We've got the Think brand, and that came over from the days of IBM when they owned ThinkPad, and we've kept that kind of quality for many, many years. And when we ship a Think product, when we build a Think product, it's built for global scale. So again, we talked about this slide previously, but we understand IoT and its challenges. It needs to be rugged, longer product life cycles, right? Device management. How do I do life cycle management? Increased need for security and encryption, and easily integrated with your products and your processes. So we understand a lot of this. And we know things need to be global. So global availability, service, and support, no matter where your business takes you, we've got you covered in over 180 countries globally, on 6 continents, 36 manufacturing facilities. You can source globally from us, and you can be supported globally from us in dozens and dozens of languages around the world. Local currency you can buy in, and you can ultimately get same-day on-site warranty, repair, and support, and premium service from us in over 180 countries. So thank you, and I think we have plenty of time now for some questions.
That was great, Charlie. Thank you. Does anybody online have a question?
Very interesting presentation. Thank you.
Thank you.
Thanks, Mark. I do have a couple of questions.
Sure.
That's okay. Am I allowed to ask?
Yes.
Okay. Can you go into vibrations a bit? I noticed that's one of the sensors that you're using. What are some of the things that you can learn from vibrations?
I think from vibration analysis, you can look at, like in machine tools. It's a big thing with machine tools, and so when a drill bit is vibrating wrong, that part's not going to be manufactured precisely, especially in a precision machine tool. So you're manufacturing, let's say, a disc brake or I don't know, so for one of your bulldozers or for an automobile, and there's a computer program running on that machine tool. Machine tool basically is a metal machine. There's drilling machines, stamping machines, all these different machines. But let's say it's a drill bit. If that thing's vibrating a little bit even, that computer program doesn't know that, so it's going to basically etch that disc brake wrong or that part wrong or that clutch wrong. Now you're going to have a faulty clutch, and now that's going to cause problems out in the field. Well, so if you can do vibration analysis, you can basically know whether or not that drill bit should be replaced. And you can start to see that vibration sooner than later. Also pumps. There's a lot of pumps and pumping systems in a lot of machines. And if they start to go bad, you want to basically change their oil sooner than later. Things that start vibrating only because maybe it just needs oil change. So maybe it's time to change the oil if you're seeing vibration. So you can do condition-based analysis to know, oh, I need to change the oil in that. I didn't have to, do what do we call not preventive, preventive maintenance, where you change the oil in your car every 3,000 miles or 5,000 miles. Well, maybe something really bad happened. Maybe I hit a pothole, a rock came up, and now I'm leaking oil. I didn't know it. I got to change my oil in 10 miles, right? But how do I know that if I don't have an engine oil problem light? So vibration can be an indicator of needing to change oil. It can be an indicator of a bad drill bit. And there's many other use cases for vibration analysis in the factory. And they can correlate a lot. I'm seeing a lot of machine builders want to correlate that with the PLC data. So a lot of these machines already have sensors in them, but they might be 10 or 20 years old. So they're going, I think we've been calibrating them properly for the last 20 years. Maybe I should get a modern day vibration sensor or a modern day temp sensor and double check my calibrations, right? So I'm getting the data from the PLC about vibration data or temp data. Is it correct? So we're seeing a lot of new sensor projects, sensorization projects, even when the machine already had those types of sensors.
What about something like a motor grader or wool tractor scraper out in the field? And is there vibrations there that can send an early alert prior to maybe a breakdown?
Absolutely. In fact, one of the greatest stories I ever heard was I don't know if it was vibration or not, but I was listening to a Caterpillar use case. I forget the guy's name. One of the IoT guys said there was a downtime of a mining machine that was a $650,000 cost for the repair, and 900 hours or somewhere 300 hours or I forget how many hours, some ridiculous number of hours, which is measured in months, I guess, and $600,000. And they said that if that operator had implemented, your Cat Connect or Cat whatever software, that they would have caught this, and it would have been a $12,000 repair, and it would have been scheduled downtime during regular downtime. And I thought that was like, wow, talk about an ROI. That's pretty incredible. But yeah, absolutely. There's all kinds of analysis you can do in vibration analysis to fix a problem on either a tool, maybe it's even just a backhoe part. Maybe it's the hydraulics arm. Maybe it's in the motor of the heavy equipment. It could be on many different points that you want to measure vibration, but absolutely out in the field, so your customer has a better experience, and you can start to predict some of these problems before they break down and give the customer better ROI and better uptime. It's all about uptime and reduced cost to repair those machines.
Absolutely. I have more questions. So I'll just go ahead and ask. So with your hardware, right, that you have your telematics device that's out there, and you talked about security. Do is this a one and done security, or do you how do you make sure it's always keeping abreast of the latest security threats that are getting, created by the bad guys?
So I'd say that we have some of the most brilliant security people in the world working for us. We've got a really, really strong security team, and security, obviously it's not out of the box and off the shelf. They have to have governance and how do I basically implement the right security architecture? What are the right technologies I need to, what policies do I need to implement? So there's a lot that goes around security. It's not just about what stack do I use, what protocol stack do I use, what SSL or TLS stack do I use. So we have teams of people that will come in and work with the customer. We have a lot of security that is built in, and through APIs, you can access those security features of our edge computing products. We have what we call Think Shield. It is a defense in-depth edge security strategy around that device, protecting that device. There's a lot of configuration around that. So you don't have to write any kind of secure stack. You just configure Think Shield on our Think Smart products. We use TPM, which is basically becoming the norm in the industry, which is basically a secure separate processor for security key locker. So you don't have to secure your keys locally on the processor, which are basically can be potentially hacked. So it's much harder to hack the security keys. So there's a lot of things we're doing, but we're also coming in architecting end-to-end security, either with our customers or with their systems integrators.
So if let's say you have a device that's out there in the field, it's been there in the field on one of our customers, pieces of equipment for the last, let's say 5 years, and we need to update the security on that. Do we have to buy a whole new device, or can you do an update and update the firmware?
So we have some platforms, our own device management platforms. We can do software updates. If the customer wants some different features and functions that maybe some of our device management platforms can't do, we've got partners that's all they do is device management. So we work with people like Cumulocity, people like Teles with their device-wise stack, and people like Edge IQ. There's a number of device management companies. So we don't play favorites. In many cases we will basically let we vetted a lot of partners. We narrowed it down from, let's say, 20 device management platforms to 3. But we'll say, hey, you can talk to all of them. We think these are 3 of the best out of the 20 or 30 out there, or 200, because most people don't know where to start. So we help the customer in that way. So again, we have our own internal device management tools to do those software updates. But again, there's third-party tools as well that we can recommend.
Okay, and I assume that's over the air flashing.
All over the air flashing, absolutely.
Great.
You have to, because I mean, you can't make the business case if you can't do over the air. I mean, IoT cannot scale without device management. So. Great.
Do you guys offer a service at all for, you said you can provide this and ship it all over the world? It's certified in 180 some countries. Do you also do the import and export documentation that goes with that?
That I don't know. Garrett or Jonathan or somebody can help me out. Well, I got my entire team here.
I can take that one. So Lenovo, which is a little unique to the industry, unlike an HP or Dell, our core competitors, we actually own all of our manufacturing, well, at least a good chunk of it, especially in this market. So we've actually gone out and certified what we call a global shipping and carton label that allows our integrators to take a device within the country, like the US, and confidently ship to, I think it's more like 160 for this OEM program with some caveats in certain companies, but you can confidently ship the device through customs, integrated in your machine without any hassle, more or less.
Great. Okay. Thank you, Garrett. You also had talked about 5G. So do all of your products support 5G now, or is this something that's coming out in the future? Has it been certified?
So definitely 4G today. 5G is coming in our next gen products. Our Gen 2 products are coming out in April, and we're going to have some friendly customer partner trials, let's say, come end of December or January, probably.
Okay.
But yeah, 5G. Our products will launch with, they have 5G today, but they will launch with both 4G and 5G in April of next year, April-May timeframe. So which is fine, because, I mean, if you look at 5G today, I mean, I can't even get 5G at my house right now. So I mean, look at my phone. I've got a 5G phone, but it's not getting it. It hasn't been really deployed at scale yet. We're still going to see, it's going to take another year or so before 5G is really implemented at scale. So you got to be both 4G backwards compatible with your chipsets, and you have to also be 5G ready for next year at scale. And I think really 2022 is going to be the real mass rollout of 5G. People are going to really start testing and validating and get everything working next year. And then 2022 is going to be the big rollout. It looks like Ed might want to, I don't know, Ed, you trying to say something? You're on mute, Ed.
I'm agreeing with you. I think it'll be a hybrid environment for the next couple of years.
Ed, can you share a little bit about what we're going to be doing with our 5G? You know more about our 5G overall strategy, some of the cool devices, the in-building devices we're going to be making, and can you share a little bit about that?
Yeah, there's a number of plants that we're actually showcasing this in China right now, where we're doing a private 5G network with a virtual baseband unit and other indoor and outdoor radio units that will basically drive some very interesting 5G applications and workloads inside a connected factory. Some of those applications will be around AR, augmented reality, to really give the kind of performance and the low latency that is required in many of those types of applications. So you're going to see a hybrid environment, but we have 3 factories right now in China that is showcasing some of the 5G private network capabilities.
Excellent, thanks, Ed. Jonathan, I don't know if you want to say anything, Jonathan. You're welcome to jump in, or if you're good, don't.
Yeah. So part of the reason why we did it in our own factory is because 5G has not been deployed at this kind of scale, and the kind of data, its amount of data that's moving back and forth over this network is very different from what we would use in our phone and our laptops.
Mm-hmm.
So we need to make sure that in a production-like environment, any other hiccups are actually weeded out. So that's part of the key reason why we do it in our own plants and factories, to make sure that we can weed out all these problems. And we are working not only in China, but with other international telecom company who will be providing 5G to make sure that these are also within the right bandwidth, within, that there's no conflict and there's nothing else. So again, I completely agree with Charlie and Ed. 2022 is probably where it will hit with a big bang, particularly in the commercial side. At this point, it's going to be very much a consumer-based implementation right now. But when you get to a more commercialized industrial mode, I think the readiness is going to be more like 2022.
Exactly. Thanks for backing me up, Jonathan. No, because it's true.
Are you guys doing any experiments with self-driving? Because I know that can take quite a bit of bandwidth.
It's big. I haven't personally, but I don't know. Maybe Jonathan. I don't know.
Depends on what the question means. Are you talking about 5G in self-driving?
Yes.
Or okay. So that is obviously being
in the factory. In the factory, you're talking about like cars out on the streets of Los Angeles.
I'm thinking about a job site.
Okay. And a job, think of like a mining facility, Jonathan, or think of
Yeah, there's no activity right now in that area, but certainly that's one of the considerations, right? The first thing is if we can push the volume problem-free in a factory type environment, where the volume is really high and where any problem you can expect is probably going to be weeded out. Then I think rolling it out to a more remote areas like mining sites and so on, those I think will be much easier to handle. So there's not going to be much difference. The core technology are similar. It's just a matter of coverage.
But Jonathan, or do you know, have we been involved in any autonomous vehicle initiatives, let's say inside of a warehouse, maybe a robotic forklift or a robotic pallet mover, or anything like that where our compute might have been embedded, or are you not sure?
Yeah, not specifically on 5G yet, but
anything. It doesn't have to be 5G. It could be on a.
So there are two things. One is within a factory, we have actually built technologies around the robotic vehicles. So we've created, as an example, a 3D camera, spatial camera, which you can mount on those vehicles, and you could actually communicate with the navigation system, right? So that again is one of the things that's there. I mean, traditional robotic vehicles follow a red line or a yellow line in the factory everywhere. and if you put an object in its path, it's going to crash. That's why they have a special aisle on the side to make sure that people walk on those aisles, very much like our traffic or actual roads. So we do build technologies around that for that. On the other side, though, I'm not sure if you're familiar with the car NIO, NIO. That's like the China Tesla.
Okay.
So it's pretty big. It's also listed in the, I believe, the New York Stock Exchange under the code NIO. Lenovo has taken a small stake in that as well, and we do incorporate some of our technologies into the car.
Great. Good.
Thank
That's a
you.
good discussion. Very good. Does anyone else have any questions?
I have a question.
Great.
Sure, I'll start my video here. Hi, Charlie. That was a great presentation you did earlier. Really appreciate all the information there. My name's Jim Montalongo. Our company is Engineering People. More recently, we've been designing AR/VR type applications for training. We have a new really big customer that has hundreds of users, and so we're getting into this whole thought of what this training application, since it also includes some testing, wanting to get over to that AI portion of it, and just wondering if you have any examples with that, just to maybe help lead us a little bit in that direction.
I personally haven't been involved in any major ARVR projects yet, but either Jonathan or Ed can talk to that. I don't know who. Ed, who would be better, Jonathan or you?
I think Jonathan has a better handle on it. I'm aware that we have a number of AR projects, especially around remote hands. There's a group that we have in Santa Clara, California, that actually has a lot of use case scenarios around that, Jim. So we'd be happy to kind of put you in touch with them.
And they're very focused on industrial ARVR. It's not just like, it's not for kids fun at home or whatever.
No, this is all
not
about
consumer. It's industrial.
Yeah,
So.
This is all around the enterprise. A lot of our conversations is around the manufacturing plant of the future for the remote hands, teletraining and the like, as well as some discussions around a food and beverage company in their production line.
Very good. So we'll be deploying this to their tablets, and so we're just looking at we're still building right now, so we're kind of figuring all these pieces out right now. It's something this large we haven't done before, so I'll get.
There's a whole team of experts. We have an entire ARVR expert team. We could bring in the vertical experts from that team if we want to have a call.
Yeah, just last week, Jim, we briefed the CEO of that food and beverage company to show him and demonstrate and reflect a number of directions where AR, because one of our team members is the president of the AR Association. So that'll kind of give you some perspectives of how we look at it from an industry association standpoint. It'll give you some ideas of what we're seeing in the marketplace.
Excellent. So how do I get contact information, Shannon?
Jim, I got your first name and last name, so I can find you on LinkedIn.
Okay.
Permission granted.
That's a good point, Jim. It'd be good to have a slide that had some contact information on there.
Yeah.
Great.
Yeah, that's a good idea. I'll update the presentation.
What a concept.
But you could always, if for some reason you don't get contacted or you need to contact, I do have Charlie's phone number and his email address.
There you go, Charlie.
My cell phone number is 561-573-8322. If you have an opportunity, you are more than welcome to call me. Email is cmcniff, C-M like Mary, C like cat, N like Nancy, I like India, F like Fox, @lenovo.com. So either send me an email or give me a call.
And by the way, I was working on a master's program. I had the opportunity to visit Lenovo, and I believe it was Beijing where we were at. So this was back in like 2004, a long time ago. So
before we acquired the ThinkPad group from IBM.
It was right after.
That was 2005. We acquired them in 2005, so it's probably right around that time. Yeah.
So Jim,
Oh.
I found you on LinkedIn. You're the CEO of Engineering People, right?
Yes.
I'm sending you a LinkedIn invite now. And Peoria always reminds me of my tenure at Caterpillar when I was a machinist at the fuel injection plant in San Leandro.
Awesome.
Awesome.
I miss those days.
Simpler, huh?
Yeah,
Yeah.
they were.
And Jim, when this COVID is over, more than welcome to come and visit Beijing again. We've transformed significantly since 2004. We now have a huge briefing center, which shows the technology of the future and use cases. Everything from smart home, some smart living style, right, to smart transportation. So I earlier mentioned about the NEO, the Teslas of the of China. We actually have a model of that in a briefing center itself, and many other stuff. So more than welcome if you happen to come to this part of the world.
Thank you very much, Jonathan. I may take you up on that sometime here. So
Sure.
I think my 10-year visa is still good for another 3 years, so maybe I will too.
Charlie, bad news. Every visa you have right now is invalid.
No. Oh, that's
You have
right.
to reapply because of the COVID.
Ah,
Got it.
got it. Okay.
Okay. Anyone else for discussion for the group? All right, hearing none. I just want to thank you very much, Charlie, for your presentation. It was an excellent presentation. I think very engaging and a lot of great information. And I would like to thank the Lenovo team as well, you guys, for all the support that you provided. And I'm looking forward, I know, to the meeting tomorrow morning at Caterpillar. So
Yeah, me too. Very excited. Thank you very much, Shannon. I really appreciate the opportunity for both today and tomorrow. And I think I look forward to working with you in the future.
Thank you, guys. Have a good evening,
Thanks.
ladies and gentlemen.
yeah, have a great day.
You too.
Thanks,
Bye.
everyone.
Okay.